Hello and hi everyone. This project focuses on the fabrication of a peristaltic pump by applying fundamental machining and manufacturing process. Throughout this project, we perform several machining operations such as benzo cutting, lead turning, milling, drilling, taping, and surface finishing to produce each component accurately. During the fabrication process, we emphasize workshop safety, machining precision, and teamwork to ensure every part met the required specification. Finally, this report also discusses the challenges we encountered, the solution implemented, and several recommendations to improve product quality and manufacturing efficiency in future projects. Thank you.
So next, let's go to safety equipment and technique. By following personal protective equipments, individuals need to wear a safety boot, safety goggles, safety glove, safety jacket, and safety pants.
We use several techniques in this project. Number 1 is milling process. Next is cutting process. Therefore, we have grinding process. Next, we have drilling process. And we have boring process. And last one, we have the turning process.
So now, I will explain about manufacturing steps process for lathe machine and drilling. The first step is switch on the power supply and check the required speed on the lathe machine. Next, put the cutting tools on the right position. Step 3. Put the workpiece in the jaw and tighten the jaw. Step 4. Align the cutting tools to the workpiece. Follow the right dimension. Step 5. Cleaning up the workpiece surface by cutting it with the right dimension. Next, drilling in the middle of the workpiece to make a hole. Step 7. Enlarge the existing hole by using a bigger drill. Next, continue enlarge the existing hole using right tools, follow the required dimension. Step 9. Finish the turning process following the required dimension. Next, cut off the required workpiece using different cutting tools. Next, after finish cutting the workpiece, drill 2 holes on the workpiece, then make a thread using thread tools. Drill off 2 holes on the workpiece to put the required tubes. And the last step, finishing it by spray the spray paint on the workpiece.
Manufacturing step process. Milling. Measure following size requirement. Milling to clear surface of workpiece and follow seat required. Cutting off clean surface area. Grind corner of the workpiece to get curved shape. Drill the workpiece after marking with center punch for making a hole. Testing a suitable drill bit for making counter boring. Boring at the top side workpiece following countersink head screw depth. Tapping at both side drill hole with M6 tapping size.
So next, I will continue to explain the problem faced and solution for turning and finishing. The first problem is inaccurate diameter. The machine diameter did not meet the required specification. It will cause incorrect measurement and excessive depth of cut during machining. So, our solution is, the workpiece was measured repeatedly using a vernier caliper and a light finishing cut was performed to achieve the correct dimension. After we make the solution, the final diameter met the required specification. So this is the video of evidence of inaccurate diameter. For the second problem is rough surface finish. So the workpiece surface was rough and showed visible machining marks after the turning process. It will cause high feed rate and worn cutting tools. So the solution is, the cutting tool was replaced, the feed rate was reduced, and a final finishing pass was performed. So after we made the solution, the surface became smoother and achieved a better surface finish suitable for painting. So this is the evidence of how we overcome the rough surface finish.
Before, the workpiece is cut directly to its final dimension before undergoing the milling process. Because of this, the workpiece becomes too small and short, making it impossible for the milling machine vice to grip it securely. For the solution, we reverse the process sequence by milling the raw, longer workpiece first to achieve the desired surface finish before cutting it to its final size. And after it, the workpiece can be clamped securely, ensuring a safer operation and making the subsequent machining step much easier. To create a rounded oval edge on the workpiece, we script the curve using a workshop divider compass and use a handheld grinder to shape it. However, the process was time-consuming, inaccurate, and often result in overgrinding. Because of this, we handheld grinding lacks stability and control, making it difficult to maintain the correct profile and dimension manually. So the solution is we switch up to using a bench grinder, measure the precise angle degree of the curve and mark the exact boundary line with a marker before grinding directly to that line. And after that, the grinding process becomes significantly faster. Dimensional accuracy was achieved and material wastage from overcutting was eliminated.
Moving on to the discussion section, here are the key takeaways from our process. First, we improve machining accuracy by utilizing precise measurements. Second, enhancing the surface finish is crucial for better overall product quality. Third, we managed to reduce machining time through proper process planning. Fourth, regular tool inspection and maintenance must be performed consistently. And finally, we strictly apply safety practices throughout the entire fabrication process.